Hello, welcome to another Algebra 2 lesson. This is lesson 5.1, Objectives, simplifying with nth roots and rational exponents, and solve equations with nth roots and rational exponents. Nth roots, we have square roots, cube roots, fourth roots, and nth roots. N can be any number we want it to be. An example of a square root of 9 is 3, because 3 squared equals 9. Roots and exponents undo each other. They are inverse operations. When you are simplifying square roots, you pop out pairs. 9 is 3 times 3. When you have a pair of like factors under that radical that's a square root, it pops out because you have 2 of them. So when you're doing a cube root, you're looking for sets of 3. Fourth root, pop out sets of 4. Nth root, pop out sets of n. Cube root of 27 is 3, because 3 cubed is 27. Fourth root of 81 is 3, because 3 to the fourth is 81. Nth root, as long as this n matches, b to the n equals a if the nth root of a equals b. Nth root, n is called the index of the radical. If there is no n written with the radical, then it is a square root. So when it has an invisible index, it's a 2. Let n be an integer, n greater than 1, and let a be a real number. If n is an even integer, a is less than 0, no real nth roots. So if it's negative, there is no real roots. Remember, they are imaginary though. When a equals 0, one real nth root. The nth root of 0 is 0. When a is greater than 0, there are 2 real nth roots. So we have to worry about a positive and a negative, plus and minus square root. So plus and minus square root, plus and minus fourth root, plus and minus sixth root, whenever n is an even integer. So when the index is even and the number inside of the radical is positive, we have to worry about 2 real roots. When n is an odd integer, like a cube root or a fifth root, if a is less than 0, so negative number, then there's 1 real nth root. When a equals 0, there's 1 real nth root. And when a is greater than 0, there's 1 real nth root. Notice 1, 1, 1. So when your index is an odd integer, there's just one answer. If it's a negative inside the radical, you get a negative answer. If it's a positive inside the radical, you get a positive answer. Find the indicated real nth roots of a. Example 1. So the nth root, so we want to find the cube root of negative 216. So the first thing we need to realize is this is a negative, less than 0, so there's 1 real nth root. It is going to be a negative. To know what the cube root is without using a calculator, we need to break down 216. Prime factor tree. If I divide by 2, get 108. Divide that by 2. It's still even. I'm going to keep dividing by 2 until it's not even anymore. Oh, 27. 27, I'm going to branch out this way, is 9 times 3. 3 times 3. So let's write out those factors in order. Remember to use only the ends of the branches. So we used a 2, 2, there was 3 2s, and just the ends of the branches, there were 3 3s. Look at your index. We're doing a cube root, so we're looking for sets of 3. We have 3 2s, so a 2 pops out. We have 3 3s, so a 3 pops out. Don't forget our negative that we already took out. 2 times 3 is 6. Final answer, -6. Now, you can check it on a calculator. Most calculators have a cube root. Scientific calculators, it's usually on a math button or an nth root, and then you tell it which root you want to do. Easiest way to check is to do -6 times -6 times -6, and you get 260. Next one, fourth root. Fourth root of 81. So 81 is 3 times 3 times 3 times 3. Remember, if a is greater than 0, there are two real nth roots, so we're going to have positive and negative because we have an even index. We're looking for sets of 4. We have 4 3s. So since we have 4 3s, that's one set of 4, one set of 4. So we get 1 3 on the outside. Plus and minus 3. That means that 3 times 3 times 3 times 3 is 81. And also -3 times -3 times -3 times -3 is also 81. And that's example 1. Rational exponents, fractions. Roots and exponents are inverses of each other. So you can switch between radical form and exponential form. So the square root of a is really a to the 1/2 power. Cube root of a is a to the 1/3 power. Fourth root of a is the 1/4 power. Fourth root of a cubed is equal to a to the 3/4 power. So the root, the index, is your denominator. The numerator is the power. Look at this example. This one, a to the m over n equals the nth root of a, all of it to the m power, or you can put the m inside, nth root of a to the m. If you have a negative exponent, remember negative exponents give us reciprocals, and that would be 1 over nth root of a to the m. So this one is the one we're going to refer to often that you want to make sure you have this in your notes so you remember which one goes where. The denominator is your index on your root. Let a to the 1/n be an nth root of a, and let m be a positive integer. So here it is again. A to the m over n equals a to the 1/n times m, because remember, when you raise a power to a power, you multiply the exponents, and then you get nth root of a to the m. Evaluate each expression. So what we're going to do is break down our 16. 16 is 4 times 4. We want to write this as a power of prime numbers. So this is 2 to the 4th. So 16 is 2 to the 4th power. And then we have the 3 halves. We can multiply. So this would be 2 to the 12th power. 12 over 2, and 12 over 2 is 6. 2 to the 6, 2, 4, 8, 16, 32, 64. All right, that is one way to use this information. Let's do this one more way. 16 to the 3 halves. Use your 2 as your index, so that's a square root of 16. Ooh, we know the square root of 16. And then don't forget about that 3. That numerator is going to go out here. So I'm writing it like this one. Square root of 16 is 4. And 4 cubed is 4 times 4 times 4. 64. Same answer. Two different routes to get there. So this first one, I did more of a break it up into two separate numbers. And the second one I did this way. Right? Negative exponent. 32 to the negative 3/5. So since we have a negative exponent, we're going to write it like this one. Negative exponents give us reciprocals. So this is 1 over 32. Because this is a fraction, we're going to put it in a radical. The denominator becomes our index. And the numerator becomes our exponent. So 32 is 2 times 2 times 2 times 2 times 2. It is 2 to the 5th power. So 2 to the 5th power to the 5th root. We're looking for sets of 5. So the 5th root of 2 to the 5th power is just 2. So we get 1 over 2 cubed, 1/8. 2 times 2 times 2 is 8. And there's our final answer. That's example 2. Example 3, approximated expressions with rational exponents. Evaluate each expression using a calculator. Round your answer to 2 decimal places. So when you put this into a calculator, you're going to use the 9, and then you're going to use that button that has the up arrow that's called a caret, and then parentheses 1 divided by 5. So you're raising it 9 up to the 1/5 power, and you get a decimal that goes all the way across your screen. So your calculator itself is rounding. We want to round your answer to 2 decimal places. So 1, 2. We look to the only to the digit, not the 8. 8's not important. Just the one just to the right of the place value we're rounding to. If this number is below 5, we just get rid of it. And our answer is 1.55. If that place value was 5 or bigger, then this 5 would have gone up to a 6. So final answer, 1.55. You have to round correctly. All right, 12 to the 3/8 power. Type it in. Remember, a fraction bar is just a division bar, so you're just typing in 12 up to the parentheses 3 divided by 8 power, and hit enter. Remember, we're only rounding to 2 decimal places, so we only have to look at that one and this one. None of the other numbers actually matter. So when we get rid of these, this was a 9, so this goes up to a 4. And there's our answer for B. 12 to the 3/8 power is 2.54, approximately. All right, now we have to find the nth root button. Chances are on the button that has the caret, right above it, it has an nth root. And mine is in blue. So I have to hit my blue button on my calculator, the second function, and then this button to get to the nth root. So once you hit that, then you can type in the index and the number inside. Some calculators, you actually have to type in the 4 first. So for mine, I'm actually using just a scientific calculator, not a graphing calculator right now. So I'm going to type 4, then my second button, then the caret because it has this nth root above it, and then I'll type in my 7. And then I'm going to hit enter. And then I'm going to cube it. So then I'm going to go up again to the third power. Now, had I remembered before I started, you could also put the parentheses in ahead of time and then do it all at once and not have to hit enter. So you need to practice that on the calculator that you have. And see if you can get to the same answer I'm getting. .30. Check your answer. All right, I typed mine in 2 different ways. I'm doing enter for the parentheses and then raising it up to the third power. Or if you type it in from the beginning with parentheses, your 4 second function caret, so you get up to the nth root, type in your 7, close your parentheses, up to the third power. You'll also get 4.303517071, which rounds to 4.30. And that's example 3. Odd and even roots. You can take odd roots of positive and negative numbers and get only one answer, either positive or negative. For example, cube root of 8 is 2. Cube root of negative 8 is negative 2. You can take even roots of only positive numbers in the real number set. So in other words, if you're doing an even root of a negative, you could get an imaginary. But for the most part, even roots, we're going to stick to the positive numbers, especially if it's a 4th root or 6th root or any of those other even indexes. You have 2 answers, positive and negative. For example, 4th root of 81 is plus and minus 3. 4th root of negative 81, no real answers. Any root or power of 0 is 0. Okay, so even roots, we're looking for 2 answers. Odd roots, you get just 1. Solving equations using nth roots. Find the real solutions. All right, here we go. We are going to isolate the power and then undo the power using nth roots. So the first thing we have to do is isolate the power. X to the 5th is being multiplied by 4. Undo multiplication with division. Four goes into 12 3 times. 4 goes into 8 2 times. So that's 32. Undo the power using a root. So we need to undo the 5th power, so we're going to do the 5th root. It is an odd root, so we only need one answer. If it's an even root, we need a plus and minus. So x equals 32 is 2 to the 5th power. So the 5th root of 32 is 2. And that's our answer. Isolate the power, then undo the power with the root. Example 4b. The power is already isolated. X minus 3 to the 4th equals 21. I'm just going to rewrite it. So I have room for my root. Undo powers with roots. This is a 4th power, so we need a 4th root. 4th root of 21. Because it's an even power, we need to do a plus and minus. So plus and minus, well, 21. If we break that down into prime factors, we get a 3 and a 7. They're definitely not 4 of anything. So it's plus and minus 4th root of 21. Oh, equals x minus 3. Not our final answer, because x isn't by itself yet. But the 4th root undid the 4th power, so now we just have this x minus 3. Not done until x is by itself. Isolate the variable. Add 3 to both sides. Three plus and minus 4th root of 21. That's our final answer. And that's example 4. Isolate the power, then undo the power with the root. If you're doing an even root, do plus and minus. If you're doing an odd root, you just use the sign of the number that's there. If 32 is negative, this would be a negative 2. But 32 is positive, so our answer was a positive 2. Even roots, 2, 4, 6, 8. You need a plus and minus. Exit ticket. Ooh, almost done. Evaluate 49 to the 3 halves without a calculator, and then evaluate this one with a calculator. All right, pause here, give it a try. Break down your 49 into prime factors. Pause your video, give it a try. Square root of 7 squared is 7. And then to the 3rd power, 7 times 7 is 49. 49 times 7, 343. And then this one with the calculator. Start with your parentheses. Parentheses. You got to find your cube root, second function, nth root. Depending on what kind of calculator, you might have to put that in first. So I have to do parentheses 3, then tell the nth root. Negative 24, make sure to use the negative button, not the minus. Close the parentheses. And then up to the squared power, up to the 2nd power. And we get round it to 2 decimal places. It didn't tell us what to round to, so we're going to round it 2 decimal places, 8.32. All right, and that is your notes and your examples for lesson 5.1, rational exponents. When it says rational exponents, rational numbers can be written as a fraction. So that was your warning, rational exponents, that you were going to get fractions. Remember, the numerator is the power, the denominator is your root. And if you are having a hard time remembering that, just remember your typical square root of x is x to the 1/2 power. The half power. This was a square root. When there's no index, it's invisible too. So square root is x to the 1/2 power. That is a helpful piece of information. Big Ideas assignment 5.1, hop to it. Let's get started on your assignment. Have a great day. Thanks for watching.